So let's take a look at another keyword that we can use in Java along with try and catch. And this keyword is finally. And the purpose of finally is to make sure that you execute some part or some code no matter what happens. And what I mean by this is there's a couple of execution paths that can happen when we put a try and catch block into our code. The first thing that can happen is this printer.print could not throw an exception, in which case it's just going to go on past this. So it might go on to whatever lines that we have down here and just keep on running, and it'll exit this method. So it'll get to the end of this method, and that's the normal execution flow. The other thing that could happen is that we could end up throwing an exception in our printer.print, and then we'll catch the exception, and then we'll hit this line of code. Now, in this case, maybe we would want to do a return. Maybe we return early here, and we don't keep going down the rest of the method. In that case, we're going to miss out on what code is down here. So one way that we can prevent that from happening is to use a finally block here. So what we do is we create another block below the catch, and we call it finally, and you put code in here that you want to happen no matter what. So in our example, let's turn off the printer no matter what happens. After we're done making copies, if there was an exception, let's turn it off. If there wasn't, let's turn it off. So let's go ahead and run this code the way it is right now, where it is throwing that exception. In fact, let's put a return statement here just to be sure that when we catch this exception, we're getting out of here. And we want to see that this printer is still going to turn off. So I'm going to run this code, and you can see it said can't print less than 0 copies, but we don't really have a message in our turn off. So let's put a message in here real quick so we can see what is going to happen here. We had put one in for our turn on. Let's put one in for turn off. We'll say the machine is off and save this. Okay, now let's run this and see what is going to happen. So now you can see it's printed can't print less than 0 copies because it got here because it threw this exception, and then it still returned, but before return it actually hits this finally block. So finally happens no matter what. And we can demonstrate that this will happen even if we don't hit an exception. If we go into our print method, and instead of checking copies, let's just comment this out. So this is not going to get executed, so it will actually try to print a negative number of copies. And we'll run this, and you can see it's gotten all the way down to the load more paper, and then it hit this machine is off. So in this case, it went through, it went ahead and executed this, it never threw an exception, and then it made sure to hit the finally block. So finally is really useful in scenarios where you need to make sure that some code gets executed no matter what. And this is going to be, a lot of these scenarios are things like where you have to do some kind of cleanup. Maybe you grab a file or file handle and you need to close that file even if you had failed to read it, because you don't want to leave that file open. An operating system has a limited number of file handles that can be open at a time, and you don't want to leak file handles. You don't really have to worry about memory so much in Java because of the garbage collection, but you do have to worry about resource leaking, which is basically any time that you would grab some kind of limited or finite resource and then not dispose of that, not clean up that resource. Files are a real good example, but there's a lot of them that exist out there, and really finally kind of solves the problem, because without finally we would have to basically repeat our code. We could do the same thing here. Instead of this finally, we could call printer.turnoff here, and then we could call printer.turnoff here and get rid of this finally block. But the problem with that is that we're going to be repeating this code, and if our error handling code changes or the way we turn off a printer changes, we're going to have to update that in 2 places. So that's really the simple use of the finally statement in Java. So in Java, there are basically 2 types of exceptions. The 2 types of exceptions that we have are checked exceptions and unchecked exceptions. And these 2 types of exceptions kind of exist in Java for some reasons that are kind of a little bit debated. And as we talk about the checked exception, you'll kind of see what I'm talking about. But just so you're aware, this is kind of a unique thing for Java. And I don't really know of other programming languages that have checked and unchecked exceptions. And because of this, it creates some division and some confusion for Java developers. But I'm going to try to explain the purpose of each one of these exception types and generally how you use them. So let's talk a little bit about checked exceptions first. So a checked exception basically is an exception that either needs to be caught, you have to have some catch in your method. Wherever that exception can be thrown, it must be caught, or you have to specify that your method can throw that exception, which then places that burden of being caught on whatever calls your method. So this basically works to set up a rule that a checked exception has to be handled. You have to do something specifically with it. You can't just ignore it. And so a checked exception really forces error handling into your code. It really forces you to deal with exceptions. And this is somewhat debated because it kind of forces your hand. Like I said, you have to deal with the exception. It can be a little bit of overhead in Java. A lot of times you just want to open a file and you don't want to deal with an exception. But because of the way that checked exceptions work in Java, the compiler won't even compile your code. It'll give you an error if you haven't put some code that could potentially throw a checked exception in a try block, or you haven't made it so that you declare that your method can throw that exception, and then it ends up getting thrown up the chain. It's a very formal way of dealing with exceptions, and kind of the idea behind this was to ensure that the proper conditions were checked, that error handling existed in the code. It kind of made it so that the compiler could do a better job of determining whether or not your code was handling the conditions that could happen. And checked exceptions all are basically subclassed from exception. If we look at this diagram here, you can see this is kind of the hierarchy of exceptions in Java. Everything inherits from throwable, every exception type. And from there you have error, and you also have exception. And the ones that I have in red here are ones that are checked exceptions. So there's kind of this exception to the exceptions, which is basically everything that inherits from exception is checked, including exception itself, but runtime exception. Anything that inherits from runtime exception is not checked. So all of the red area on this diagram are checked exceptions, and that means that you must either catch them or specify that your method is going to throw that exception type. So if you created new exceptions in Java, and you wanted to create checked exceptions, you would basically inherit from exception. And when you're creating exceptions, or when you're dealing with exceptions, the rule to remember with checked exceptions are any kind of exception that code would be reasonably expected to handle. So it's an error condition where your code should be able to do something useful. And a good example of that would be if you try to open up a file, but that file doesn't exist. Well, I mean, you could detect that condition. You could reasonably give the user an error message saying that file didn't exist. To contrast this to your program ran out of memory. So let's look at a quick example of checked exceptions. I kind of want to show you this so you can see how a checked exception operates. We're not going to really look at unchecked exceptions because we kind of already covered that in the try and catch. Basically, an unchecked exception, if you remember, you don't have to catch it. It's not going to cause a problem if you don't catch it. You can if you want to. And that's kind of what we did with this illegal argument exception. But a checked exception, remember, you have to catch this exception, or you have to say that you're going to rethrow that exception or throw that exception again. And or basically say that your method is going to throw that exception. So I'm going to show you a little bit of file I/O here. We're not really going to cover the file I/O, but I'm just going to show you this because I know that this method is going to throw a checked exception. So I'm going to create a file here using the file class, and we're going to do a new file, and then I'm going to specify this file will be c/test.txt, and we're going to try and create this file. You can call file.createNewFile to create a new file. Now what you'll see happen here is, see, we've got this squiggly line in Eclipse, and it's telling us unhandled exception type IO exception. And since IO exception is a checked exception, we either have to add a throws declaration or surround with try and catch. And these quick fixes are pretty handy in Eclipse, so I'm going to go ahead and show you how to use both of these. So let's click add a throws declaration first. Now you can see here it's adding this throws to our method, and we can choose IO exception, exception, throwable. The more specific one is probably better here, so we'll choose IO exception. And so now it lets us get away with this. But this is really a bad habit here. A lot of people will basically do this, and then kind of ignore the exception in order to just write their code. If this is telling you that it throws an exception, you should really try and handle it if you can. Now, it's okay to throw it back up if you have some code that's going to handle it up the chain and that's the more appropriate place. But what this is indicating when we put this at the end of a method is that this method is capable of throwing this exception. And it's kind of deferring that responsibility of catching the exception up the chain, if that makes sense. So the other alternative that we could do is we could actually catch this exception ourselves. So I'll look at these quick fixes again, and I can surround this with a try catch. And you see it's auto-generating this code for me. It's basically just wrapping our call inside of this try catch and catching this exception. And then it automatically prints the stack trace as default, but we could do something here, and we could actually even rethrow an exception. And I'll show you this point real quick here while we're in this area of rethrowing an exception. The other thing that you can do, we saw here in the printer that we could basically catch an exception and print out a message. We can also rethrow an exception. So for example, we could take this IO exception and we could wrap this in a new exception, an exception class that we created that's more specific to what we're trying to do here. Maybe we created a printer exception, and I don't have one created, but let's just say we had a printer exception. We could do throw new printer exception, and then we could make this take our existing exception and then add some other message. And this is kind of a common pattern. I didn't want to get too into depth here since this is more of an introductory level course, but just so you know that this is out here, this is a good way that you can just rethrow an exception. If you can't do anything really smart with the exception here, it's good to go ahead and catch it, but then maybe you have some more context that you can pass around here, and so you could throw a new exception that might mean something higher up the chain. But that's the basics of using a checked exception, is that if you use a checked exception, or a class that throws a checked exception, you either got to put this in the try catch block, or you can add the throws at the end of your method.